Electric motor. In our daily life, we see many electrical appliances like fan, washing machine, etc. In all these devices, there is a rotating part that rotates after it is provided with an electric current. How is this electrical energy converted into mechanical energy in these appliances? These devices have motors which facilitate this conversion. Let us go through this module to learn more about electric motors. In this module, we will study about construction of electric motor, working principle of electric motor. Let's make an arrangement which gives us rotatory movement. The main parts needed for this arrangement are insulated copper wires, armature, a magnet, 2 split rings, 2 conducting brushes, electric power source, battery. How will we assemble these parts? Let's see. Take a magnet whose north pole is placed on one side and south pole on the other side as shown in the diagram. This type of magnet will have a uniform magnetic field. Now, place a rectangular conductor coil, also known as armature, inside this magnetic field. Connect the 2 ends of the coils to the 2 halves of the split rings, also called commutator. This completes the basic framework of the motor. All that is left now is connecting a power source to the motor. For that, these split rings are connected to the battery through the conducting brushes. An electric motor works on the principle that whenever a current-carrying conductor is placed in a magnetic field, it experiences a force. In our diagram, current enters the coil PQRS through brush X and flows back to the battery through brush Y. Here, the current in the arm PQ flows from P to Q, and in the arm RS, it flows from R to S. As current flows in the coil and it is placed inside a magnetic field, both the arms experience a force. We apply Fleming's left-hand rule to find the direction of the force. According to Fleming's left-hand rule, if the thumb, forefinger and middle finger of the left hand are stretched to be perpendicular to each other as shown here, and if the forefinger represents the direction of magnetic field, the middle finger represents the direction of current, then the thumb represents the direction of force. The force acting on arm PQ pushes it perpendicularly downwards, while the force acting on arm RS pushes it perpendicularly upwards. As a result, the coil starts rotating about its axis in anti-clockwise direction. After half rotation, connections of the split rings with X and Y are reversed. So, the direction of the current flow is reversed in both PQ and RS. As a result, the direction of force on PQ becomes upward and on RS becomes downward. The reversing of current in the coil is repeated after every half rotation, due to which the coil continues to rotate as long as current from the battery passes through it. Thus, by reversing the direction of the current in the coil, the direction of the force on both arms also reverses. A device that reverses the direction of the flow of current is called a commutator. Here, the split rings act as a commutator.